Hello everyone, welcome to new class. Today's class is the continuation of matrices. That is, in the previous classes we have discussed about the inverse of matrix using elementary operations. So let us do some more problems related to this inverse using elementary operations. So next question is obtain the inverse of the following matrix using elementary operations. A is equal to matrix 0, 1, 2, 1, 2, 3, 3, 1, 1. So let us do the elementary row operation. So let us do the elementary row operation. So for that we have to write A is equal to I into A. Now put the value of A and I. 0, 1, 2, 1, 2, 3, 3, 1, 1 equal to I is 1, 0, 0. So this is 3 by 3 matrix. So we have to write the 3 by 3 matrix of this I matrix 0, 0, 1 into A. Now here we have to make the first element of the first row 1. So this is 0 here, and look that any other row contains the element 1. So here this element is 1. So we can interchange these two rows. That is R1 interchanged with R2. So first row and second row are interchanged. So it will become 1, 2, 3. Next 0, 1, 2. That is these two rows are interchanged. 3. The third row remains unchanged. So the same change we have to make here also. So these two rows are interchanged 0, 1, 0, 1, 0, 0, 0, 0, 1 into A. Next task is make this element and this element 0. So this element is 0 here. Now we have to make the third row's first element is 0. So for that we can write R3. R3 implies R3 minus, that is multiply this one with 3 and subtract. So 3R1. So R3 minus 3R1 implies we will get this as 0. So here we will get these two rows are not changed 1, 2, 3, 0, 1, 2. So here in the third row 3 minus 3 times R1 is 0. Then 1 minus 2 into 3, that is 1 minus 6 is minus 5. Then here 1 minus 3 into 3, that is 1 minus 9 is minus 8 equal to, here also these two rows have no change 0, 1, 0, 1, 0, 0. So in third row 0 minus 3 times this one 0, 0 minus 3 times this one, that is minus 3, then 1 minus this one, so it is 1 into A. Now our next step is make the second element in the second row 1. So here it is 1 itself. So our next step is make the elements above and below this 1 0. That is this element we have to make 0 and also this element we have to make 0. So in the next step we can write this R1. So R1 implies R1 minus 2 times this one. So 2 times R2. Similarly R3 implies. So R3 implies R3 minus, here this is minus 5. So R3 plus 5 times R2. So that we have to do here. So here we will get 1 minus this one, so it is 1. Then here 2 minus 2 times this one 0. Then here 3 minus 2 times this one, so 3 minus 4, so it is minus 1. Then here 0, 1, 2, no change. Next is change in the third row. So here we will get R3 plus 5 times. So here both are 0. So 0. Then minus 5 plus 5. It is 0. Then here minus 8. So minus 8. Then plus 5 times R2. That is plus 10. So here we will get 2. Now in the RHS also we have to apply this rule. So here we will get R1 minus 2 times R2. So 0 minus 2 times this one, that is minus 2. So here we will get minus 2. Then 1 minus this one. So 1. Then next is 0 minus 0. So it is 0. Then next row same. Then here we will get R3 plus 5 times R2. So here we will get 5. Next is minus 3 plus this one, that is minus 3. Here 1 plus 5 times, that is 1 into A. So our next aim is make this one, that is third element in the third row or the last element 1. So to make this one as 1, we have to divide that with 2. So R3 implies R3 divided by 2. So here we will get 1, 0, minus 1, 0, 1, 2, 0, 0, then 1. So similarly here also we have to apply that 1, 0, 0. Here we will get 5 by 2 minus 3 by 2, 1 by 2 into A. So our next aim is make this 0 and this one 0. That is R1 implies R1 plus. That is here this is minus 1. So R1 plus R3. So in the next step we have to make this one 0. That is R2 implies R2 minus 2 times R3. So here we will get 1, 0, 0, 0, 1, 0, 0, 0, 1 equal to, here also we have to apply this rule, that is R1 plus R3. So minus 2 plus 5 by 2, that is minus 2 plus 5 by 2. So here we will get minus 4 plus 5, that is 1 by 2. Then here 1 plus minus 3 by 2, that is 1 minus 3 by 2 is 2 minus 3, that is minus 1 by 2. Then 0 plus 1 by 2, 1 by 2. Then second row 1 R2 minus 2 R3, that is 1 minus 2 times R3 is 1 minus 5, that is minus 4. Then 0 minus 2 times this one. So 0 minus means it is plus, 0 plus 3. So it is 3. Then next is 0 minus 2 into R3. So 0 minus 2 into 1 by 2. So here we will get minus 1. Then next one 5 by 2 minus 3 by 2, then 1 by 2 into A. So in this side we have got the identity matrix. So this is in the form of I is equal to A inverse into A. So here what is A inverse? So A inverse is this one, that is 1 by 2 minus 1 by 2, 1 by 2. Then minus 4 minus 4 3 minus 1. Then 5 by 2 minus 3 by 2, 1 by 2. So A inverse is this one. So in this way we are doing the elementary row operations. Let us do another problem. Obtain the inverse of the following matrix using elementary operations. So given matrix is A is equal to 1, 3, 2, 7. So for the row operations, we have to write A is equal to I into A. So put the values 1, 3, 2, 7 equal to I is 1, 0, 0, 1 because A is 2 by 2 matrix into A. So our first step is make the first element 1. So here it is 1 itself. So next step is we have to make the below and above elements of this 1 0. So here only one element here. So we have to make this 2 as 0. So it is row 2. So R2 implies R2 minus 2 times R1. So here we will get 1, 3. Here it will be 0. Then here 7 minus 2 into 3. So 7 minus 6 it is 1 equal to then here 1 0. So in the second row we have to apply this rule. So here we will get 0 minus 2 times R1. So 0 minus 2 into 1. So it is minus 2. Then next is 1 minus this one. So 1 minus 0 is 1 into A. Next we have to make the second element in the second row 1. So here it is 1. Now we have to make the element which is above and below to this 1, 0. So here we have to make this element 0, that is R1. So R1 implies R1 minus 3 times R2. So here we will get 1, 0, then 0, 1 equal to, here we will get 1 minus 3 into minus 2. So 1 plus 6. So it is 7. Then here we will get 0 minus 3 into R2. So 0 minus 3, that is minus 3, then minus 2, 1 into A. So this is in the form I is equal to A inverse into A. So here what is A inverse? So A inverse is equal to matrix 7 minus 3 minus 2, 1. So this is A inverse. Let us do another problem. Obtain the inverse of the following matrix using elementary operations if exist. So if there is inverse, we have to find it. So first of all, we have to use the row operations. So elementary row operations. So we have to write here it is P. So P is equal to I into P. So put the values here, that is 10 minus 2 minus 5 1 equal to 1 0 0 1 into P. So here first step is make the first element 1. So here this is 10. So to make it 1 we have to write R1 implies R1 divided by 10. So here we will get 1, then minus 2 by 10, that is minus 1 by 5, then minus 5 1 equal to, here also we have to do this rule. So R1 divided by 10, that is 1 by 10, then 0 0 1 into P. Next we have to make the element which is below this 1 0. So this element we have to make 0. So here this is minus 5. So R2, this is R2. So R2 implies R2 plus 5 times R1. So here we will get 1 minus 1 by 5. Then here it is 0. Then here 1 plus 5 times R1. So it is minus. So minus 5 into 1 by 5. So here we will get 1 minus 1. So it is 0 here. So here we get it as 0. So here also after applying we will get 1 by 10, then 0. So R2 is R2 plus 5 times R1. So 0 plus 5 by 10, that is 1 by 2. Then 1 plus this one, that is 1 into P. So here, look that here this one row is 0. So in the previous class we have discussed that if one or more rows in this LHS is 0, then inverse of the matrix doesn't exist. So here P inverse doesn't exist because one row is 0. So here one row is 0. So P inverse does not exist for this matrix. So that is about the problems related to inverse of the matrix using elementary operations. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.